fixing programming, or building your first trillion-dollar company. There are low-level languages and high-level languages. In a low-level language, you talk to the hard drive in a way that the hard drive wishes to be spoken to. In a high-level language, you open a desktop window with a simple bit of code. High-level languages have a concept of an object that is really fun to write out and play with. For example, people create or program window objects with actions like open or close. And then you create an instance of that object. And once you have it active, once you have it in your hand, you can say, window, open. And then the window just pops up. You can point it at a web page or put some input boxes and a button in there to have the user say something like username and password, login, or some such. Sometimes objects are used to create more powerful objects. Orbs, nay, glowing orbs connected by wires which send little messages back and forth. Or actions that have a concept of before and after, where you can add more actions, kind of creating these strange little necklaces of programs. And this is where the party flops. Any programmers that venture beyond this point simply unravel. They may make some games, maybe card decks with fun user interfaces that you can drag and drop together, maybe virtual worlds. But it all falls apart here. People don't do anything special beyond this point. And if they try, they end up with what has been referred to as leaky abstractions, where, for example, windows can no longer be opened or something equally mangled. There are also folks here who have been taught to map out low-level stuff with objects. They create objects like hard drive or a file with a documents property that explains where the documents folder is. They just code themselves in a circle. They use high-level tools for creating concepts of low-level things that are already coded and done. And they create an unreadable mess of nonsense code that nobody really needs. Programming for programming's sake. Practical applications of object-oriented programming are discovered by poets and artists, not engineers who just graduated college. And unbelievably, there is a point here where you just call the program done and let the users do all the programming, because there is only a handful of cranky engineers and 1 million of cheerful users. So this here is a higher level programming language where you don't have to worry about low-level stuff or the high-level stuff, but instead really well-rounded concepts. In fact, if you need a special bit of functionality that needs to be filled with standard programming, be it low-level or high-level, you only describe what you need. With a behavior-driven development-like language, which is pretty English, and wait until that functionality becomes a puzzle, or more precisely, a robot that you and other users can use in the programs. You'll find that there is a lot of room here for exchanging money. For example, you can put a bounty on a new feature. And then, if you are the owner of the system, you can take a small percentage of the bounty that was set to support your system. Usually, you don't want to charge the users a lot of money because they don't have that. You want to charge the companies doing business with you in a way that is proportional to to how much money they have and how much money they can afford to spend. The programs that you may wish to build are the same or similar to what leading internet companies are doing, except you are making them with a higher level language where it is trivial and clear to understand. Kind of really beautiful. The first problem that you have to tackle is your monthly server bill, and this is cheap and easy. When a user signs up for a developer account with your company, they have to bring in their own server. The server will have a standard spreadsheet-like database called a SQL database, and whatever pieces of the puzzle that they use or bought. If the server is on the cheap side, which I guess it should be, but they have a spike in traffic, then it is their responsibility to turn on a second one, which will jump into processing the queue of actions that are taking too long to be solved by the server. It is better to launch a couple, just in case, and as the traffic dies, they will shut down, having been in operation for hours. That too is not very expensive. Yeah, it makes sense to offer a premium service where you take care of all that, but I like application creators to bring in their own hardware or servers and accept some extra responsibilities like the content that is stored on those servers. It's smarter that way. Now, with your network being ever expanded by the users, let's talk about the higher level language. If you happen to be a software engineer, you might want to stop listening now, because this will mess you up. We have to start with beauty, class, and tradition. So the user interface will be a work of art, almost like no other. On top of that, it is actively beautified by users. And your first user interface theme is nothing less than a fascinating pixel art creation with a heavy undertone of retro futurism. It will look like a computer game, or more precisely, like a utility program from the old days of Commodore and Amiga. Investing into beauty and art is important. Your users will actually understand everything you are doing by just looking at the screenshot. In fact, the screenshot will not only haunt them, but they will return to your system with a back-of-the-envelope sketch of a custom program that they always wanted to use, or invent, or develop, or own. Now that we have the servers, or more precisely, distributed self-provisioning server architecture taken care of, now that we have the beautiful user interface that users are always welcome to improve with more breathtaking pixel art, let us look at the language itself. It is, of course, very simple, very friendly, and requires absolutely no learning. It is a world of rooms that have doors to other rooms. This creates a graph or a tree. This not only allows to categorize things in a user-friendly way, similar to files, folders, and windows and desktops and buttons and such, but also allows for creation of simple to reason about processes or state machines or factories in which robots dwell on assembly lines. And that is accomplished with the concept of a package or a box that contains things in it. In network programming, I guess one would call this a packet. It can, for example, contain a picture, that a user may want to convert into a painting. This package is addressed to an artist in the system. Then the user will be notified when it is looked at, approved, queued up, and when the progress of the task changes and finally reaches completion. The most important object in the system is the user. And here, the users can move around the system, interact, create forums, or write on the wall if you like, and of course, add new rooms with new assembly lines and new bots. And users have inventories. They have a key to their own private area and whatever administrative rooms they built up as part of creating their inventions or factories. They have a passport with memberships to private communities, for example, and coins that can be spent on purchases and purchased, of course, another way for you to make money. Similar to a user is the bot. Bots help with tasks such as creation of a specific package, or designing a new package from scratch for some new purpose, or transforming some piece of data with some other piece of data. These bots or robots are extremely powerful. They can, for example, create art. They can write poetry, create computer programs, and they can even analyze medical x-rays. Because a bot can be powered by a group of human users. In the case of x-rays, a group of doctors from all around the world. And it should be customary that before a human-based action is taken, a consensus must be reached, and then further verified by the more human participants. This way, you can actually write a program that cleans up the city. People put a bounty on, then workers from any neighborhood, just normal people, are sent out to make the repairs or temporary repairs or cut grass or pick something off the road. And then another worker is sent to verify that the task is complete. So a bot is like a front-end user interface to groups of people. It's really, really cool. This is, of course, very similar to, for example, a jury room, which has 12 users that are performing a very complex and simple yay or nay task. Or how a self-checkout register, which is a robot, uses humans to solve problems that they can't deal with or comprehend or understand. For example, if you have a tomato without a label on it, the computer program will not be able to understand what is going on. It will then say, "Oh, I don't know what to do. I'm going to call a human," and then the human will come over, take care of it, enter the PLU code or some such, and then the computer will complete its task, or the robot will fulfill its task. So this is not a new invention. This is a very old invention. Finally, you need an efficient and simple way to automate lots of little things. And you should start simple and easy at first. Later, your users will fill the system with all kinds of fantastic new objects that you can't imagine right now. But at first, simple and easy is the way to do it. So you create a factory out of rooms that accepts certain kinds of packages. These packages are then processed by bots, sent to another room, and processed by more bots. Your factory does not need to be linear. It can be a tree or a graph. Based on some condition in the package can be sent to a different room or to a different group of bots. The packages that enter a room are stored in a simple queue, and I recommend that you use the concept of an assembly line. The bots then are attached to it in a sequence, and this will help you group small tasks without the need for networks and networks of rooms. And that's it. That's the whole thing. It is a virtual world that everybody already understands. There are no leaky abstractions here, just a handful of easy-to-grasp things. To start creating this system, put a bounty out for the most delightful implementation. And maybe, at the same time, organize a little contest for the smallest and most creative implementation, just so that you get an idea of how small this whole program is. Either way, do emphasize small but clear and easy to read code. Source lines of code-wise, this is not a large program, and it is really fun to write.